Hey boys and girls, welcome back to Munro Live. We're here at New Labs, and this is right downtown in Detroit, right across from the new Ford building, which used to be the train station. And I'm here with Tu and Jack, and they're going to introduce themselves. Tu Lee, go first.
Tu Lee, I'm the managing director at Sandy Munro Insights, but most importantly, also I wear two hats. I'm also the EIR at Teardown Detroit. I'm a member of Newlab, so I thought Sandy invited him down to come check out all the entrepreneurs.
And I'm Jack Gray. I'm the head of industry memberships here at Newlab at Michigan Central. Excited to host you all here. Excited to show you around.
Good deal. Well, let's go and see what you got.
Perfect. So if we can go this way, this building was originally built as the mail sorting depot for the Michigan Central Station next door. So as you think about all of the mail that was coming in off the trains, as the trains were essentially distributing the mail for Michigan and the Midwest out of the station there, this was the main mail sorting space for the trains. So there's tunnels connecting the buildings and all that kind of thing.
No kidding.
What it is now is a hub for hardware manufacturing and entrepreneurship here in Detroit, Michigan, and the Midwest. So what we really focus on is early stage startups that are particularly in the hardware space, not exclusively, but mostly, helping them get through those early stages of growth, right? So the pre-seed, seed, Series A, how difficult it is to get through those early days. How do we support them with space and infrastructure to actually build out their solutions? So we'll tour around, but as you can see, there's space for them to make their pitches and host their meetings and build their business. We've also got about $15 million of manufacturing equipment in the back that we're going to walk you through.
Where did the funding come for that?
They can build this. So this is this is very much part of the Michigan Central campus that was originally funded by Ford Motor Company. So the station, the building here, and other buildings on the 30-acre campus is all funded through that mechanism. But there's a big reason you don't see a big blue oval on any of the buildings here, because it's part of the Ford vision to be much more than a Ford effort, right? So there's all sorts of other OEMs, tier ones, and other large industry partners that are part of the relationship, part of the ecosystem here. So it's pretty exciting to be part of that network.
Well, you very seldom, excuse me, you very seldom hear about, the big OEMs dishing out a tremendous amount of money to help out innovation. Yeah. That is amazing.
And it's tangible. It's not, I do a lot of hand waving, but it's not hand wavy. We want startups to come here from around the world to build their thing around the world, right? And so have the space to build their technology, build their solution, and then go test it. So we're part of the Transportation Innovation Zone here in Detroit. So what used to take multiple months of permitting can now take days to go get permitted to go test any of these solutions in a 3-mile radius here. Similarly, working with the FAA to do drone testing above us, one of the only urban testing zones in North America. So you come here, you build your solution, you quickly test, iterate. You could potentially get funding from Newlab in Michigan Central as a startup. So Newlab's made 50 or 60 investments, $100,000 to $300,000 range. So not everybody gets an investment, but everybody gets a look. And then finally, we work with industry partners to help them commercialize. So everybody who's here is what we consider to be venture backable, and really working with them to help connect them into industry partners where they can test, deploy, pilot, commercialize, and grow.
Cool.
Right? That growth path is tremendously important.
So looking at this, these I assume are electric bikes. Are they all made by the same company, or?
A few different companies are making micromobility solutions here. So less about the actual mode itself and more about the ability to make them quickly.
Yeah.
Right? So we have a few companies, Bloom is one in particular that focuses on building those micromobility solutions, small scale manufacturing, really flexible manufacturing for early stage startups in this space. So providing them with the expertise to build out these solutions quickly. You can see in the background a drone from DMR. DMR is another member company working on building a variety of different types of drones for different agricultural and commercial settings. And then finally we have a lot of autonomous solutions that we'll keep on walking through and see some of those as well. So keep asking questions. This is what we do. We want to highlight our startups. We want to highlight the technology that's being built here. As you can imagine, we spend a lot of time on what we call the broad spectrum of mobility. So wheels, wings, and water, that's what we particularly focus on, and the manufacturing, the advanced manufacturing that supports that world. Other new labs around the world focus on other kind of hard to solve industries like oil and gas, mining, energy, urban development, things like that. But here in Detroit, we focus a little bit more, and our partners at Michigan Central are critical to helping us unlock that as well.
What are we looking at here?
This is one of our newer members.
This looks like a underwater kind of.
Exactly. So as part of that wheels, wings, and water, on the water side, we really try and lean into the Great Lakes and how do we support new technologies in that space. I believe motmot, I have to actually get the exact details, but my understanding is it's a sub for tracking and different propeller technologies as well.
Yeah, so my name's Elliot, co-founder of motmot. My past is I was a civil engineer. I helped represent a number of cities and counties as their direct engineer. And I realized there's a whole world underneath our feet of drinking water infrastructure that we just don't have visibility on. And if you don't have visibility, it's really hard to manage your most critical assets. So what we do is we put an inspection device into our water main distribution and transmission systems to get video, look for leaks, look for the geometry of the system. And we leverage that data back to the city so they can do better asset management.
Well, every year we wind up with water mains that blow up in the wintertime and whatnot, and that usually causes a lot of grief. And for some people, it wrecks their life because the water main blows up, fills up their basement, and ruins everything. So yeah. This is a really good idea, I think. I really like this idea. So here you've got illustrations, and I've seen this a little bit.
Yeah.
But are these things actually in production? Are you actually doing inspections now?
So this is what we currently have. This is our Generation 1 MVP. The way that we have it separated is we do straight line inspections. So going from a corner of a city to another corner, straight line, just through the municipality. This can get you about 6-8 miles max. And again, huge value, right?
Yeah.
What we want to do though is shrink it down to this guy and start to make a turn. This is our second generation.
Yeah.
If you can make a turn within your municipal infrastructure, you're going from like 7 miles of inspection to like 500 miles of inspection.
Wow.
With like a single entry. And that's the business model. And right here, you're seeing like kind of our anchoring mechanism. We operate during low flow conditions. So when everyone's asleep, no one's flushing the toilet, taking showers, it's a perfect time to inspect. During the day, when we have like a higher peak volume, everyone's brushing their teeth, you have a bigger demand on the system. We don't inspect during those times. Instead, we just anchor ourselves, let the flow of water recharge the batteries so you can go back out the next night for reinspection.
So they regenerate. So it's just like a car going down a hill.
Yeah, it's just free energy that we're using.
Yeah, good idea.
Thank you.
I love it.
That's really good idea. So when do you expect to have this thing, ready for prime time?
So we're testing right now at MSU, U of M. We have a decommissioned water main in East Lansing that we've been using. Our first pilot is actually next month at Michigan State in their live system. And we got about 12 municipalities across the state for doing the straight line inspection. Next March is when I want to start doing the turn pilots. But yeah, next month was our first kickoff.
Elliot, how much have you raised?
We just finished our pre-seed round in December. We raised about $1.34 million.
It's a beautiful thing. And one last thing, why Newlab in Michigan Central? Why here?
Great question. So I went to school at Wayne State. I grew up a little bit west of here. I got my MBA from Michigan State. Very Michigan oriented.
Yeah.
But right here, I like to tell folks like this is the epicenter of Midwest innovation. You have tons and tons of resources, a huge community to help develop it.
Ecosystem partners?
Yeah, ecosystem partners like Teardown Detroit, Newlab, MEDC's upstairs. If you want to get things done, you have to throw yourselves into the fray of that community and really treat it like a team sport. And then it's a lot better to get things done.
And Jack, I'm going to put the shoe on the other foot because I think the entrepreneurs also need to teach the ecosystem partners how to move
100%.
faster, how to cooperate with small companies, individuals, entrepreneurs, where there's the traditional automotive space has been very rule and policy oriented.
Yes.
I think breaking things and moving quickly is something that's very new.
Oh, it's huge.
So-
Yeah, it's huge. Like here you can get things done. And that's like really important as a startup because like your runway is only so long.
Yeah.
So you kind of need to move fast, and like having folks that can move just as fast as you and to get those things done, like that's why we're here.
All right, so we've got Arnold here from Intermode. You want to talk a little bit more about what you're doing?
Sure. So what we're building is autonomous mobile robots. So we're more like a commercial chassis provider for robotics. And so we lease out our platforms. We help customers go launch quickly out in the field so they can focus on autonomy, customer acquisition, rather than how do I build small electric vehicles. And so we've got some of our first parts here we're building for a customer. So these are panels that we 3D print on our 3D printers upstairs. So these are carbon fiber PETG, pre-processed. We've got our frames out here that we get bent. So I think you'll appreciate the entire lower section and most of the walls is one piece, and then we rivet on pieces on the side. We use a lot of prototype sheet forming to do most of our early chassis work. Basically, how do we no tool most of our designs is the main goal here. Now, this particular customer really wants a very fancy exterior body, and so you'll see some of the fiberglass panels upstairs, but we mix and match fiberglass panels with 3D printed panels for low volume manufacturing. Yeah. Cool. And so we've got, more 3D printed parts. I'll grab some of those over there. Let me grab some of those on the other side. So these are roughly 4 hours each to print. Same thing with these. So everything we do when we 3D print it, it's optimized for 3D printing. So we have everything is in increments of printer nozzle width. Everything is increments of how to quickly do this. So we've run it out. It needs about 100 units of volume, 150 units of volume before we even start to like approach break even for even doing low volume injection molding, or even casting for that matter. So we do a lot of 3D printing work and optimize for 3D printing work to really get these low volumes out there. And this is a printer that I designed and built ourselves.
Oh, really?
Well, I didn't want to pay $20,000 for a hunk of garbage. I'm like, well, if it's going to be that, I'll build my own, right? So we built 6 printers. One of them we sold to a company in here, and then the other 5 are operating upstairs, making parts for us all the time.
So you could have bought it for 20 grand. How much did it cost you to build it yourself?
About 3.5.
3,500?
3,500 in BOM, probably another 1,500 in intern labor, so about 5 grand.
Wow.
Yeah. And so they produce parts all day long.
Wow, maybe you should go into that business.
I've heard that one before, yeah. So, yeah.
Well, let's go up and see it.
Yeah, let's do it.
Yeah.
Those are shop milestones for the shops team. So we, here at Michigan Central, we are right in between 2 of the oldest communities in Detroit, Corktown and Southwest. And Southwest is home to a large
that's awesome.
Mexican population. And so one of the best grocery stores in the area has some of the best piñatas in Southeast Michigan. So
Wow.
like I said, some shop
And some of the best
milestones.
Mexican food too.
Exactly. Right above the entrance to the 3D printing space. So 5 to 10 different printers, different fidelities, different abilities to produce at different speeds. So that is something, again, where we can help teams either learn how to use the tools themselves, and in Arnold's case, they're building their own. In others' case, they just want to build a few parts and then they keep moving.
Yeah.
So giving them the flexibility to do so. And then we do jobs for our Brooklyn team. Our Brooklyn team does jobs for us. So we're able to actually kind of share some of the capacity there as well.
Oh, excellent.
We designed the body to be modular, so we put this body in here, and then we sort of had all the smarts and electronics, like autonomy, computer vision, all that up here. So that way we could leave like a giant body inside and that goes all the way through.
Wow.
To have really smart, and it's not exactly, it's 47 inches by 23 inches.
Yeah.
So we can ship 2 on a pallet really cheaply anywhere in the country.
Cool.
So this is the one we developed and designed as Intermode to be a super efficient body. And then we're also developing another one for a customer out in California. So this is the one we're designing for them.
Oh, wow, that is snappy. Oh, and there's that piece you just showed me.
Yep. And so, but yeah, it's meant to be a giant cavity inside for groceries, delivery and whatnot. And then what we do is we have a single piece of like the fluted polypropylene that we score in the corners, and we fold that as sort of the surround inside, and then a polypropylene fluted floor as like a really cheap solution. And
Well, the other thing is you get insulation too. You get it for,
exactly.
You get double.
Exactly. Now this customer's wanted to be super weight sensitive, so this is a carbon fiber door. I think eventually this will be made out of something different. But yeah, and then on the back side here, you can see sort of the full like electronic setup for like their stuff. So that way we isolate between chassis electronics, chassis locomotion, movement, and then sort of customer autonomy and whatnot. Yeah.
Wow. So we just had somebody that came to us for advice on how to design. They have a little delivery robot.
Yeah.
It's for Europe. And I asked them, why is it so small? I mean, there's no volume here.
Yeah.
Europeans generally are smaller
We
than
designed
Americans.
for a 400-pound gross vehicle weight rating. So for the bare chassis, and so this body weighs about 90 pounds.
Right.
And so we're left with about 160 pounds of payload in this one.
How much battery power do you have in here?
So these
How
have
many
about
kilowatt?
3 kilowatt hours. So it's a 36 volt 10S Samsung cylindrical cell system. We're going to switch over to a Cato prismatic setup with about 5.3 kilowatt hours for the next one. But everything we did in low voltage, everything we did in like, yeah.
Low voltage, like 24 or
48,
48,
36.
Yeah.
We also developed a mechanical e-stop system. So in the event of a power outage, the solenoid triggers. This one's a little beefy. We haven't optimized it out yet. But so even if the system loses complete power, the BMS fails, the battery fails, the robot will still come to a stop on its own. Yeah.
Cool.
How fast does it go?
So the top speed of this one's 25 miles an hour. The customers
Wow.
will be using it at 10 to 15 miles an hour for active use.
Yeah.
So that's a big difference between the sidewalk robots, is that it can actually be useful. Because if you're just going 3 miles an hour on the sidewalk, it's not super useful. Whereas this can carry a full load of groceries, deliver it to someone's house, because an hour range at 15 miles an hour is actually a pretty good delivery range to solve suburbia. Yeah.
What about security? Like, how do you get it so someone doesn't steal the groceries or whatever?
Well, so this door will be powered closed, right, and locked. So they won't be able to open it. Eventually, we'll probably also add some sort of lock to it.
So like the customer needs like a pen or something to get into it? Or?
It depends on the use case. So some customers will put, like, you put up your phone to the camera. Some of them recognize it. Eventually, we want to just leave it there for the customer. So the customer doesn't have to interact with the robot. The robot dispenses whatever it has inside it, and then it drives away.
All right, so we're here with Ron Butler from ESSPI, talk a little bit about fire suppression systems.
Wow. Cool.
Yeah.
I can hardly wait.
Ron, can you tell us a little bit about what we're looking at?
Yeah.
So we're funded by the United States Department of Transportation, PHMSA, and a little bit from the DoD to develop intelligent battery logistics systems. So we look into smart ways of containing control, thermal runaway events. Also, more importantly, how do we detect early, sometimes weeks in advance, through multiple platforms? We communicate outward, so we're a 24-hour-a-day monitoring system. We can detect early, a couple parts per 10 million of an off-gassing event. We like to be very flexible on the form factors.
Yeah.
I can show you some when we go in one of our labs.
Yeah.
But we started out being funded by those organizations to develop packaging. And we quickly realized that a lot of people are doing packaging.
Yeah.
So how do we make multiple form factors that allow organizations to protect themselves using something bigger and better than just packaging? So we're on a full funding mission from PHMSA, phase 1s, phase 2, phase 2B, and we're moving into 3. We're their first ever phase 2, 2B, and 3. So they've never done that high phase work with anyone. So we're very proud of that. But I can show you some of the form factors. So this is what we've been funded through 3. We're building this logistics trailer, and it has all kinds of bells and whistles. Early detection, very early parts for 10 million. Formal detection, notification. So operationally, what do I see and hear? The communications package, once we make early detection, who are we talking with? We're monitoring 24 hours a day globally what goes on inside that package. And when we make that formal detection, now we're moving into our AI drivers. Is it a false alarm? Is it, where is it in the globally? You know, what are we tracking? Where are we tracking? Who do we alert to let them know? Maybe it's a ship en route from Korea to LA. And we detected in one of the containers, which we'll show you as well, that there's a problem ongoing early. So we can pinpoint where it is within a meter. We can let a ship's captain know that you have a problem in your hull long before it becomes a real problem. Full thermal runaway event, you know, all the vestiges of thermal runaway. And then we can, some products like this, we can alert and activate fire suppression. And we're very agnostic on the fire suppression. Water-based systems are very difficult to move. So we look to inert and inert-like gases. They'll eliminate the flame for a time.
No oxygen, no problem. That's
that's kind of where we're moving to. You know, nothing is really that clear. We've done a lot of testing, and really what we're moving to is, you know, inert gases, inert-like gases.
So, in case of a incident, what's the evacuation strategy? Like, so it's sitting in because this is something that we're looking at right now.
Okay.
So you've got a container like this, and you detect an event in the process. How do you get that thing out?
So we just spoke with PHMSA about this. We're making this wheeled. Now, it will be hard to fix to potentially in-house system, so quick connect. But what we really like to do is once that's activated, once the process starts, we get an early detection. This sends a signal to your organization at 3 o'clock in the morning, right? That someone has to be there to initiate this removal. That becomes part of the SOP and part of the emergency response procedure as well.
So do you create the emergency response procedures?
We develop full scale. We're a full deck company. So not only do we design the tool, we're doing the tool design for this building right now. Not only do we design the technology, but also the process. You can have great technology, but if it's not aligned with your process, that's no good. So we do we're fully integrated. We design top to bottom, SOP, ERP to integrate with this. We have 5 major suppliers we're working with right now: GM, Toyota, Honda. We just spoke with Lucid Motors this morning. So we're bringing everyone into a wider pilot. Our thesis is if we can cooperate on these issues, safety shouldn't be a competitive issue. If we can cooperate and develop the tools for global industry, everyone shares in the input, everyone shares in the output. Then it makes things a lot easier. This is one of our engineers.
Hi.
Armand.
Hi, Armand. Nice to meet you. Sandy.
So this is one of our pieces of tech. It is a ubiquitous fire blanket. Only we have, our metrics are much higher than a traditional fire blanket. We can go up to almost 4,000 degrees before burn through at 27 minutes. Now, our intelligence is actually built into the blanket. So the ability to detect, visually and audibly notify. So we'll have an alert here, and you'll hear it. And we can communicate through IoT and V2X anywhere in the world. So if we have a car that's suspicious, you put this over it. If we have a thermal runaway event, it's contained and controlled for a certain amount of time, right? There's no perfection. But the early detection is really where we're placing our bets.
So What is this made out of? I can't tell by feeling it.
Yeah, as long as we don't touch the edges, because you might get the itchies.
So
made of
fiberglass.
Fiberglass. Yeah. Very, very high value, because we've tested a number of our competitors' blankets, early burn throughs. Like GM had their problems at factory zero.
Yeah.
I mean, those things burn through in literally a minute. It's just
Yeah. Yeah.
But ours, even from 5 inches away, we can get 1 inch away, we get 27 minutes. 5 inches away, we're getting over an hour and a half.
That's better than aluminum, that's
Yeah.
for sure.
Yeah.
It's one of our
cool.
containers. So the same systems are built into this. So we have full global eyes on the issue. So if you have a battery you think suspicious, we can, reform a container to look just like what you need. 50-gallon drums, same thing. That is a sleeve for GM modules.
For what?
GM modules, battery modules.
Oh, yeah.
So we just put the batteries in the modules, and we're getting literally 15 minutes of direct burn through. That's
15
good.
minutes. That's way better than, like I said, I have no idea why, but a lot of people are using battery lids made out of aluminum for weight savings, but the burn through is so quick.
Oh, yeah.
I mean, but some of the polymers that we can get our hands on, like I'm very unfamiliar with this, but I'm very familiar with other plastics with our fire inhibitors and whatnot, and they last 10 times as long. So this is a new one for me.
Yeah, it's one of them. Thermoprotective, just plastic.
Yeah.
We have certain components mixed in.
So what's the base material? What kind of plastic is this?
We're agnostic, right? We just, whatever the plastic presents itself as highly formable, and we've worked with a number of companies. This company is out of Israel, so we have a very good relationship with them, but we also have components and partners in Michigan.
Thank you for the tour around. This is super cool.
Yeah.
Absolutely. Good to
Thank you
meet
so much. Great meeting you. Yeah. I may be back to talk to you.
We're here.
Appreciate it. All right, so we are here with Jason Pankin and Haas Alert to talk a little bit more about the software side of what we're doing here at Newlab at Michigan Central.
Well, thank you very much. It's great to see you, Sandy.
Yeah,
And
good
thank
seeing you again.
Jack.
Absolutely.
I'm here to show you Haas Alert, a Chicago-based company that has anchored in Detroit in a skunk works to work with multiple partners on V2X technology using the cell towers, AT&T, Verizon type connectivity to save lives. And they are saving lives right now. They are live in millions of Stellantis vehicles, Volkswagen, overways, connecting to construction sites. Up here you'll see one of the arrow boards. They now have transponders. Infrastructure is getting smart. It's connected to police cars, fire trucks, ambulances, so that you know in 20 seconds instead of 2 that an emergency vehicle is coming up behind you, so you could legally move over. They could get to the crisis a few seconds earlier, which might save somebody's life or a building. The applications are quite vast when you look at the road hazards. So as a skunk works, we work on the future. Most people don't realize that every day in America, 15 cars hit trains. We can mitigate that. These flares could be equipped with transponders. So when a police vehicle pulls over to an accident, puts up flares, one of the flares could give a signal to people down the road, tell them that there's trouble on the way. We have Stellantis, we have Volkswagen. We just did a large beta program with Mercedes-Benz, which was terrific. With the city of Dearborn, we are launching nationwide, but starting there, the use of this technology. So when a school bus puts out the stop sign, that a signal goes out. So you know there is a school bus letting off children. One of the most ugly things we read about every month in Detroit is somebody dying from a wrong way driver. With Bosch and TAPCO, we have the ability to start to detect a wrong way driver and more urgently tell people down the road that those headlights you see coming at you are headlights coming at you and get the hell out of the way.
Yeah.
Nobody's ever done that. It's all over the cell towers because we don't need, like the DSRC technology worked on, that rapid latency for vehicles to talk to each other. We can't do that. But there are 20 alerts that really matter that we could do right now with literally no investment in the infrastructure. This is all software in the car and on modems and on devices. So what you would see is this is the center stack of a Stellantis vehicle. Up ahead is one of those arrow boards, a work zone. You get the ping, you look at it, you say, okay, I gotta watch up, maybe I'll get off at this exit, get out of the way. There's a lot of decisions this lets you make. So we do this with a large ecosystem of partners. So this is why we're also in Newlab, to help other providers who may be involved in the signal side, the alert side, get involved. So we have about 80 partners doing this across all of these different activities. It's been involved with Waze. We work with Wheelan. They make the lights. When the lights go on, the signal goes out, right? We can integrate all of this. It's really quite powerful. One of the other niches where there's so many accidents are the tow truck drivers. They're out there in the middle of hell with an accident, with strewn with stuff. Nationwide Towing in Dearborn is one of the largest in the country. They have 100 vehicles connected with this. We're saving their lives. And the last thing I'll show you, which I think is really important, is this company got a very big lift from the United States federal government, right? So DHS has provided them multiple grants to get the system going and to further develop it for wildfires. So you could put literally a smoke detector on trees. And if the fire spreads, the detector goes off, it gives off the signal. Don't go down the canyon. They could have used that in California. Floods, same idea. And the Air Force, you get near the wrong Air Force base, it tells you to turn around. And with the Department of Transportation, MDOT, and others. So what you have here is really a company that started from nothing 7 years ago, got a lot of traction in Michigan, has come back here, is growing nationally, and they're active in Europe as well.
Well, I'll tell you what, I was going to ask a question about tow trucks, because if there's anybody that I mean, these guys, they do a really dangerous job. And so I'm more interested in that than almost anything else. Some of these other things, I guess you should be able to identify all this, but these guys, it'd be great. That's as far as I'm concerned, that's the most important one, because I've seen near misses with tow truck drivers like there's no tomorrow. People aren't paying attention, or they think they're going, oh, I'll just go around them.
It's one of the most dangerous jobs in America.
I can't even imagine. Yeah. I would never.
The statistics are frightening.
Yeah, I bet. Hey, this was absolutely fabulous. I am so glad I found out about everything I wanted to know about. And I mean, this has really been eye-opening. I got to tell you, the building itself could be its own story.
I know.
And it probably should be. But at the end of the day, seeing all of the stuff that's going on here at Newlabs has just been brilliant. I can't thank you enough. This was absolutely wonderful.
We're happy to have you. And it is a true partnership between Newlab and Michigan Central and the broader Michigan Central ecosystem making this thing work. Couldn't do it without them. And as you said, this building's got 100+ years of history. We're excited about this next chapter. It's pretty incredible.
Well, I'm really, really impressed. Thanks again.
Thank you. Pleasure to have you.
Thank
Come
you.
back.
Yep, absolutely. And thank you for watching Munro Live.